Welcome all, welcome children. In today's class, we are discussing organic chemistry. That is second year topic, 12th standard organic chapter. That is haloalkanes and haloarenes. One of the important chapter from organic chemistry. Let's start. Ready? First question. The reaction of HCl with alkene in accordance with the Markovnikov rule to give a product 1-chloro 1-methyl cyclohexane. So the product obtained is cyclohexane 1-chloro 1-methyl cyclohexane. This is the product obtained. The possible alkene is, see, this is possible. This is possible when you take up HCl. When you take up HCl with this, the negative part will be come here and the hydrogen will be come here according to Markovnikov rule, and you will get that product. Now there is a combination. This is possible. If you take HCl, the negative part will come here and the hydrogen will come here. You get this product. So 1 is possible, 2 is possible. What about 3? Here it is not possible because chlorine and hydrogen will occupy these positions. So the answer is third choice. 1 and 2 is the correct answer. Very simple question. You know Markovnikov rule. The negative part of addendum attached on carbon containing less number of hydrogen atom. So here in this carbon, halogen will come. Here in this carbon, halogen will come. Here it can be both the possibilities, and steric reasons will influence where it comes predominantly. Okay. Next question. SN1 reaction on chiral centers. There is. You see, SN1 reaction promote front side and back side attack. In SN1 reaction, first you get a carbocation and the nucleophile attack from the front side and back side, and I am sure all of you know it lead to the formation of racemic product. Now the question in the case is, are you getting 100% racemic? Are you getting 100% racemic so that we can select option 3? The answer is not. Answer is not. There will be partial racemization. Many cases it is observed that you are getting partial racemization. Say for example, 80% racemic product and one of the 20%, any one of the product, like that. So 80% will be textolivo. That means 40-40. The remaining 20% it could be pure one of the product. So that is called a partial racemization. So usually in SN1 reaction we say it is racemic product, but don't expect 100% racemization. Many times inversion can dominate. Sometimes retention can dominate. You see, inversion more than retention leading to partial racemization. That is one of the most observed phenomena. There can be more inversion than retention and there will be partial racemization. Right? See, sometimes you are getting 90% racemic product, 10% more inversion product. Okay. So what is the total products obtained? 90% means 45-45 dextrolivo and 10% inversion additional. So one of the product will be 45 plus 10, 55 and the other will be 45. Okay. So what is the way you are getting? Suppose you are taking a optically active reactant. Suppose you are taking an optically active reactant and imagine you are getting destro and levo with 90% racemic and 10% inverted product. So what will be the total scenario? 90% racemic means 90% racemic means you are getting 45-45 you are getting 45, 45 dextro and levo. And 10% will be either dextro or levo pure. Say for example, dextro pure imagine. So what will be the total dextro? Dextro 45 here and 10 there. So dextro retain 45 plus 10, 55. And what about levo? Levo will be 45. So what is that scenario? One of the product slightly dominates. So we can't expect always 100% resmization. Many times we see that resmization occurs partially. Okay. Next question. Which can be used to prepare alkyl halides? First one can be. First one, all of you know, you can produce alkyl halide, HCl with the anhydrous zinc chloride. You get OH group is replaced by chlorine. Second one is not possible because HCl cannot break a primary alcohol without a catalyst. Third one is possible because it is tertiary alcohol. Tertiary alcohol can be broken by HCl even without a catalyst because the reactivity is greater. Order of reactivity you people have learned. Tertiary, secondary, primary. What about the last one? Last one, it is possible. That's a secondary alcohol. It is possible. So, except 2, all are possible. It is 1, 3, 4, the correct answer. Third choice is the correct answer. 1, 3, 4. Next one. Propyl bromide with NaCN. So, this bromine replaced by cyanide. The reaction will be fastest in. See, the reaction follows SN2 mechanism. Primary halide is taken. So it is SN2 mechanism. SN2 mechanism is favored by aprotic solvents. All are protic solvents except one. NN-dimethyl formamide DMF. DMF is a aprotic solvent. Aprotic solvent will favor SN2 mechanism, while protic polar solvents will favor SN1 mechanism as it is ionic reaction. Okay, so the answer is first one. Solvent affects the rate of reaction because solvents may or may not surround a nucleophile, thus hindering or not hindering its approach to the carbon atom. Polar aprotic solvent like THF are better solvent for this reaction than polar protic solvents because polar protic solvents will form a hydrogen bond to the nucleophile, hindering it from attacking the carbon with the leaving group. A polar aprotic solvent with a low dielectric constant or a hindered dipole end will favor SN2 manner. Example, DMSO, DMF, acetone, etc. In polar aprotic solvent, nucleophilicity parallels basicity. See, the reaction is SN2 mechanism and it is favored by aprotic solvent, and only one aprotic solvent is given, and that is the answer. Next one. Identify the type of reaction. See, this is involving substitution, addition followed by elimination. That is substitution only. It is benzene mechanism. It is benzene mechanism. How is the reaction taking place? Have a look at. You see, we are using sodium amide. So, amide will absorb hydrogen. Amide will absorb hydrogen and it will be removed as ammonia. And now what happens? You get a carbon ion here. And now that charge is shifted to this position. You are getting benzene. Meanwhile, bromine is removed. You are getting benzene. That's why it is called a benzene mechanism. That's why it is called a benzene mechanism. Now what happens? Now what happens? We got benzene. We got benzene. Now benzene attacked by amide again. Benzene attacked by amide again. Now amide can attack here and here. Amide can attack here and here. Suppose amide is attacking here, you get NH2 coming here and minus charge here. You see it is away from this group. It is away from this group and it is less stable because OCH3 minus coming on the para position, it is less stable. While here you find the minus charge is coming over here and that will be relatively more stable and NH2 comes here. NH2 comes here and this minus attacking the proton from ammonia and is getting back hydrogen. See, this is what it is commented: addition followed by addition and elimination. It involves substitution reaction, addition and elimination. And NH2 group preferably comes at a meta position and is referred to as benzene mechanism. Benzene mechanism. So which will be the correct answer? Only one product is given, I believe. Yes, second choice will be the correct answer. Second choice will be the correct answer. Right? All of you know a minus character at a meta position, it is not at all stable. Right? Minus character will come at ortho-para positions. Okay, fine. Next. And there is one more term. In one of the choice, there is sign substitution. Sign substitution. What is sign substitution? Entering group is positioned adjacent to one that occupying the leaving group. That is called a sign substitution. Sign substitution. What is sign substitution? The entering group is positioned adjacent to the one that is occupied by leaving group. So this is the leaving group. This is called a sign position. And it is never a sign substitution. Right? Next one. C7H8 with the chlorine, with the bromine, iron, zinc, HCl. What is the product obtained? What is the product obtained? C7H8 is simple to understand. Toluene. Toluene is chlorinated. Then chlorinated in presence of heating or light. Then bromine with iron. Then zinc with HCl. All of you understand, I believe, the first reaction is free radical halogenation. And the second reaction is electrophilic substitution. And the final reaction is reduction. So what will be the consequence? What will be the consequence? Toluene, that is C7H8, chlorination when you do, all the hydrogen in the side chain will be replaced by chlorine and you get CCl3. Now it is electrophilic substitution. Bromine will come at this position. Why? Why bromine comes at a meta position? Because of the electron withdrawing effect of CCl3. This is electron withdrawing group, a deactivating group and meta directing group. Right? We can explain by several concepts. One can be reverse hyperconjugation. So it is providing meta-directive nature and the bromine comes at a meta position and you are getting CCl3 with the bromine coming at a meta position. And now it is reduction. The side chain will be reduced and this chlorine will be replaced by hydrogen and you get meta-bromo-toluene. Answer is third choice. Hope it's clear. Next one. So the bromine comes at meta position because of the first step operation. Okay. Hydrocarbon A react with the bromine by substitution to form alkyl bromide. So this is eliminated because they provide a addition reaction. Substitution is given by free radical substitution given by this and this, which by Woods reaction converted to gaseous hydrocarbon containing less than 4 carbon atom. So this is out and the answer is fourth choice. Because if you go for this, what will be the scenario? You see, monochlorination, if you do CH3, CH2, Cl. If this molecule undergo Wurtz reaction, all of you understand the product will be butane. Ethyl chloride on Wurtz reaction, you get a butane. While, see, that is containing 4 carbon atom. We want less than 4 carbon atom, so it will be option 4. It is methane converted to methyl chloride. Upon Wurtz reaction, you will get ethane. You will get ethane. And that satisfies the condition. Fourth choice is correct answer. Next question. Compound given found to react with NaOI produced by reacting Y with NaOH and yield a yellow precipitate with a characteristic smell ANYR. See, reacting with NaOI means it is hollow form test. It is hollow form test. Hollow form test is given by, iodoform test is given by the molecule containing methyl keto group or methyl carbonyl group. You see, the molecule with the methyl keto group, that is methyl keto group, methyl carbonyl group. This is methyl carbonyl group. They are going to give you haloform test. Now, here we have methyl carbonyl group. And what is Y? Y is Y with NaOH, you get NaOI. That is iodine. So both are correct. First choice is the correct answer. Here you don't have methyl carbonyl group. Here you don't have methyl carbonyl group. Here also you don't have. All the option eliminated. Answer is first choice. Where there is methyl carbonyl group, there will be haloform test. Right? And what will be the result? This upon treated with NaOI, what will be the result? See, this part of the carbon will be converted to iodoform. You get iodoform and the remaining part will be converted to acid. You will be getting COONA, sodium salt of benzoic acid. Sodium salt of benzoic acid. Basically, haloform reaction is oxidation reaction. Okay, next. An alkene A on reaction with ozone and zinc water gives propanol and ethanol in equimolar ratio. Addition of HCl to ethene A gives B as major product. The structure of B is, so we have to identify what is A. You see, the ozonolysis product is propanol and ethanol. You can easily find out the alkene. This is propanol and this is ethanol. So this is product obtained in ozonolysis. So what is the alkene? Very simple to understand. What you need to do is just remove this oxygen and attach with a double bond. The alkene is CH3, C double bond, here CH3, CH3, that is 2-methyl-butene. This is the alkene, which upon ozonolysis is going to break here. You get acetone and ethanol. Now comes the question. This is treated with HCl. This is treated with HCl. What do you get? Marconic of addition. What is the Marconic of addition happening? H plus and Cl minus. Cl minus will come on this carbon and H plus will come on this carbon, and you get your answer. Which one? Which one? CS3, CS2, CCl, CS3 twice, isn't it? Option 2 is the correct answer. So from the given ozonolysis product, you need to identify which alkene you are talking about. And that alkene, when treated with HCl, what will be the product? That is the question. Okay, next one. I think it is clear. Next one. Yeah. See, this is what A. Upon breaking over here, you get acetone and ethanol. And this when treated with HCl, you will get that product. Elimination reaction of 2-bromopentane to form pent-2-ene is, it is beta elimination reaction. It follows Seychef rule. It is dehydrohalogenation. It is not dehydration. Answer is ABC. Answer is ABC. Fourth choice. 2-bromopentane converted to pent-2-ene. It is according to Seychef rule. It is alpha beta elimination called a beta elimination. Removal of hydrogen happens from beta carbon. And it is a dehydrohalogenation reaction. Next one. And this is what the reaction. This is 2-bromopentane. This bromine is gone from alpha carbon, and from beta carbon this hydrogen is gone, and you are getting pent-2-ene. Pent-2-ene. It is E2 elimination reaction. Next one. Which is not allylic. First one is not allylic as it is connected to CH2 carbon, sp2 carbon. First one is vinylic in nature, that is secondary vinylic in nature. This is vinylic in nature. See, this is allyl carbon, this is allyl. This is allyl carbon, that is allyl. Oh, this is not allylic. This is allylic carbon. This is allylic carbon. So there are two answers. A is vinylic. Our question is which is not allylic. A is vinylic and this is also not allylic. So there are two answers, A and D. A and D both are not allylic, while B and C are allylic. Answer given is A, but D also is answer. Why? Because this is allylic carbon, while chlorine connected to the next carbon. This is not allylic carbon. So A is answer and D is also answer. Okay. Next one. IUPAC name of the molecule. It has to be started from this side because of double bond. 1, 2, 3, 4, 5. So it is 4-bromo, 3-methyl, 4-bromo, 3-methyl, pent-2-ene. Answer is option B. 4-bromo, 3-methyl, pent-2-ene. Simple question. Next one. More stable intermediate during addition of HBr to propene in presence of peroxide is. Oh, the free radical dots are misplaced. Here the dot should come here. CS3, CS2, CS2 dot. Here also the dot should come here. CS3, CHBr, CH2 dot. Here the dot is correctly available. CS3, CH dot, CS2Br, and that is the correct answer. See, these two are the intermediate involved in the reaction. While this is a primary free radical, this is a secondary free radical. And secondary free radical is more stable than primary. You know that. So the answer is option C. And this is containing only 2 carbon atoms. Leave it. And what is the reaction happening? The peroxide will undergo a homolytic fission and you get a radical like this. And that radical absorb hydrogen and you get Br dot, and that Br dot attacking over propene. This Br dot attacking over propene and you get a free radical like this. Because this is more predominant, because it is secondary free radical which is more stable. And finally you get the product 1-bromopropane as the final product, which is against Markovnikov rule and is called anti-Markovnikov addition, peroxide effect, Karash effect. All of you know that. Remember, it is applicable only for HBr. Anti-Markovnikov addition applicable only for HBr because of the bond characteristics of HBr compared to others. Next, highest melting point. Highest melting point. Highest melting point, para-dichlorobenzene, because of the molecular closeness and symmetry. Para-dichlorobenzene having high melting point. Refer the textbook. Next. RCH2I with NaCN. RCH2I with NaCN. You will get RCH2CN. You get RCH2CN. With the NaCN, you get cyanide. With the silver cyanide, you get a isocyanide. Cyanide is an ambident ligand. With the C, you get both products. With NaCN, you get RCN, RNC. RCN is major product. With the silver cyanide, you get both product. But NC is the major product. Right? Because sodium cyanide is ionic in nature, silver cyanide is covalent in nature. That's why. So the first product is RCH2Cl. RCH2Cl. So this is out. RCH2Cl. So B and C out. Now, similarly with NaNO2, what you are getting is RCH2ONO. Sodium nitrite will promote ONO. Because of ionic nature, NO2 is freely available and carbon-oxygen bond is more stronger, predominantly happening. While if it is silver nitrate, you get RNO2. Okay. I mean predominant product. So which is the answer? This is NO2 out. So the answer is fourth choice. D is the correct answer. So with the sodium cyanide, you are getting alkyl cyanide as major product. With the sodium nitrite, you get alkyl ONO as the major product. Okay. Next. You see, it is freely available. Cyanide is freely available and it is attacking, you get a product. Here also this is freely available, so oxygen will attack to get that product. Suppose we are talking about AgCN. Suppose we are talking about AgCN, this carbon is not free. So attack happens over nitrogen. Okay, that's it. Next. Decreasing order of SN1. SN1 is ionic mechanism. So stability of carbocation will decide the reactivity. Which carbocation will be more stable? Suppose bromine goes, you get a carbocation that is highly stable due to 2 phenyl group and 1 methyl group. So 1 is maximum. 1 is maximum. If this bromine goes, you get a carbocation highly stable due to 2 phenyl group. 2 is next. If this bromine goes, you get a carbocation, benzyl carbocation, that too secondary. So the answer is 1, 2, 3, 4. 1, 2, 3, 4 is the answer, option A. While this is benzyl. Here you get the support of methyl additional. So here 2 phenyl, 1 methyl. Here 2 phenyl. Here 1 phenyl, 1 methyl. Here phenyl only. So all can give you SN1 mechanism. And the SN1 mechanism order depends on the stability of the intermediate carbocation. So carbon cation stability comes in the order. This is most stable, this is next stable, this is next stable, this is next stable, and it comes in that order. Okay, next question. SN2 mechanism. SN2. See the order of SN2. What is the order of SN2? It is primary greater than, secondary greater than, tertiary. So primary, 1 is maximum, 1 is maximum. Secondary, this is also, second one, that is also primary. Since there is a hindrance here, it is less reactive than this. So it is 1, 2. This is secondary, this is tertiary. So it is 1, 2, 3, 4. Again, option A is correct. Again, option A is correct. 1 and 2 are primary. This is secondary. This is tertiary. So this is primary. This is primary. this is secondary, and this is tertiary. Out of the two primary, this is more reactive towards SN2 because this is a hindered molecule. Okay? So the answer is 1, 2, 3, 4 again. A hydrocarbon C5H12 give only one monochlorination product. Identify the hydrocarbon. See, C5H12 means alkane. Alkane. It cannot be cycloalkane. Cycloalkane will have the formula similar to alkene, C5H10. So this is ruled out. We want only one monochlorination product, and the answer is here you will get 1, 2, 3 monochlorination product. Here you will get 1, 2, 3, 4 monochlorination product. Here you will get 1. This is the answer. You get only one monochlorination product because this carbon and all other carbon are same. While here you can get 1, 2, 3 monochlorination product. So option A, you get only one monochlorination product, but that is not the answer. Option A, you get only one monochlorination product, but that is not the answer because it doesn't match with the formula given C5H12. The formula is C5H10. While if you go to second choice, you will get 3 monochlorination product, you may try. Third choice, you will get 4 monochlorination products and more stereoisomers also. Option D, neopentane, only one type of carbon to substitute, and you get only one monochlorination product. Next one. Which of the following compounds gives this particular molecule on treatment with the magnesium in dry ether followed by hydrolysis using D2O? D2O. Answer is option D. This when treated with the magnesium, you get a Grignard reagent. You are getting Grignard reagent CH3, CHMgBr, CH3. Okay. This upon hydrolysis with the D2O, it will break here and one of the D will come here, and that is what the product given. CH3, CHD, CH3. You see, it will break here, it is gone, and one of the deuterium will come there, and that is a product. Option D is the correct answer. Okay, next. Yeah, you see here, this bromine gone, and you get a Grignard reagent, and now it's breaking here, D will come here, and you get the concerned product. Next one. RX metallic sodium ether, you get that, and the RX with the magnesium A hydrolysis, you get a B. What is B? That is the question. You see, upon breaking here, you can understand what is R. By understanding R, you can understand what is the product. Right? Yes. You see that looking at this molecule, we were able to understand the reactant molecule is like this. You see, just break over here and you are able to understand this is RX. This is RX. RX interacting with the metallic sodium, you will get this product. So these two molecules, Woods reaction, you will get that product. So from the product, you can understand what is the reactant. Now this reactant reacting with the magnesium, you will get Grignard reagent. Upon hydrolysis, it will break here and the hydrogen will be attached, and this is what the product. And the answer is option A. Answer is option A. Okay. Try to write down a question from the NCERT text. Next question. A compound X having molecular formula C5H10 react with the chlorine to form only one monochloro derivative. The product is option B. Previous question we have seen. Cyclopentane will give you only one monochlorination product because all the carbon are same. And it is matching with the formula C5H10. Formula for cyclopentane is C5H10, and that give only one monochlorination product. Answer is option B. While this will give you only one monochlorination product, but doesn't match with the formula. While others will give you more monochlorination product that you may try. Okay, next. How many monochlorination product you can get from C and D? Find out. Number of possible enantiomeric pairs that can be produced during monochlorination of 2-methyl-butane. 2-methyl-butane. How many you can get? Option D. 2 you get. 2-methyl-butane. Let's try. This is 2-methyl-butane. This upon monochlorination. This upon monochlorination. You see, suppose I am giving chlorine here. You can get chlorine. You can get chlorine. This is what the molecule. When chlorine comes here, this carbon turn chiral. This carbon turn chiral and the molecule will give you an enantiomeric pair. Now chlorine coming here and here are same. Now suppose chlorine coming here. Suppose chlorine is coming here, over here. It is not chirality because this group and that group are same. So that is not possible. Now suppose chlorine comes here, it turns chiral. Suppose chlorine comes here. This carbon will turn chiral. And that is enantiomeric. Now chlorine coming here, no chirality. So these are the two molecules which can give you chiral centers. Okay. So a chlorine coming here or here, that will be chiral. A chlorine coming here, no chirality. A chlorine coming here, there will be chiral. And a chlorine coming here, there is no chirality. Okay. So 2 is the answer. Our question is, how many possible enantiomeric pairs? D. Next. Predict the product of following reaction. Predict the product of following reaction. You see, first treated with the PBr3, this OH will go and bromine will come. Then alcoholic AOH, the product will be option A. So first it is substitution, then it is elimination. First substitution, then it is elimination. You see, first the OH group is replaced by bromine. The OH group is replaced by bromine. And then alcoholic AOH, there will be elimination reaction. Alpha, beta elimination. This bromine gone and this hydrogen gone. And you get a double bond there. Answer is option A. Next question. Correct order of reactivity towards SN1. SN1 order is tertiary, secondary, primary. This is out. Primary maximum wrong. This is out. Secondary maximum wrong. It can be B or C. This is tertiary, tertiary, secondary, secondary, primary, primary, primary. Answer is option B, because when you compare here, primary bromide, primary chloride, all of you know what is order of reactivity for halide. Iodide greater than, bromide greater than chloride. So order of substitution for SN1 or SN2, order of substitution for halides will be iodide maximum, then bromide, then chloride. So this is tertiary maximum, then secondary. Now out of primary, bromide will be maximum. Third choice. Bromine is the better leaving group. Which of the following gives a white precipitate readily with the alcoholic silver nitrate? This you can't, because chlorine is connected to sp2 carbon. This is the answer. This is the answer. This will easily give you a white precipitate because this chlorine can be easily removed and thereby you are getting an allyl carbocation. Allyl carbocation is stable due to resonance. Here also possible, but less than this. Here it is impossible as chlorine is connected to benzene ring. Okay. So the answer is second choice, allyl chloride. Next one. The structure of major product formed in the following reaction is. Structure of major product formed in the following reaction is. I think there is somebody also here. I think it's missing. Yeah, that's it. That's it. There is chlorine here. Yeah. So when this molecule treated with NaCN, this chlorine can be substituted by cyanide, while this iodine you can't substitute. This can be substituted by cyanide. So the answer is option D. You can substitute over here, but not over here, because iodine is directly connected to benzene ring, and the substitution is not so easy, while chlorine is coming on the side chain. So the substitution, here it is easy, not here. Answer is option D. Answer is option D. Next. CS3Br nucleophile CS3NuBr minus. Decreasing order of rate of above reaction with the nucleophile. Decreasing order. See, maximum attack will happen. Phenoxide, acetate, OHCH3. Maximum attack will happen over here. CH3O. This is A, B, C. Maybe this is D. So D is maximum. D is maximum. Then it will be C. Then it will be A. And then it will be B. Why? Because CH3O minus is a relatively strong nucleophile than OH minus. While out of phenoxide and acetate, phenoxide is stronger. Phenoxide is stronger relatively because acetate is relatively weak. Because acetic acid is more stronger than this. So acetate ion is a weak base and a weak nucleophile. Suppose we are assuming basicity and nucleophilicity parallels. This is a weak base. This is stronger one compared. This is much stronger and this is most strongest. So that way you can take DCAB. DCAB option A will be the correct answer. Let us see. Option A will be the correct answer. Yes. Yes, exactly. Exactly. Nucleophilic strength order is wrong. That is not a nucleophilic strength order. That is not the nucleophilic strength order. DCAB. Choice is correct. Choice is correct. Hope you understand. This is a stronger nucleophile than this. And out of this, this is stronger nucleophile than this. Because acetate having two resonance structure, identical structure, equivalent structure. Phenoxide having 5 resonance structure but not equivalent. Okay. And CH3O minus is more nucleophilic because of the electron pumping effect of CH3. Okay. But at times in solution, it may behave differently also because it is methanol, abnormal character. Whenever phenylethene treated with HBr, major product obtained is phenylethene. Phenylethene means styrene. Phenylethene means styrene. Phenylethene with HBr, bromine will come here. Marconic of addition, option B. Bromine will come on the benzylic carbon. Marconic of addition. And moreover, benzyl carbocation is highly stable due to resonance. So the answer is option B. Option B. Next. The given molecule with the concentrated HCl. Product, identify the product. See, with the HCl, this OH will be protonated. This OH will be protonated and it is converted to OH2 and that will be removed and you get the carbocation. You get the carbocation. Now, one of the hydrogen will migrate to this position and there will be a tertiary carbocation and chlorine will come there. Chlorine will come there. I will write the reaction. You see, this OH becomes OH2 plus. Now it breaks here and thereby you get a carbocation, primary carbocation, and now hydrogen will migrate to this position and you will get a tertiary carbocation, and now the chlorine is attacking over here and you get the product like this. This is the product. None of these matching. Answer is option E. None of the given is matching. See, this can be the answer, but the number of carbon atom is greater. Here the number of carbon atom 1, 2, 3, 4. Here it is 1, 2, 3, 4, 5. That's wrong. None is the answer. There is no answer. None of this. Yes, fine. Now what about PCl5? PCl5 will go for SN2 mechanism. This will be simply replacing chlorine. No carbocation rearrangement all. OH goes, chlorine comes. That's all. OH goes, chlorine comes. That's all. Option A. Option A is the correct answer. Option A. So with HCl, there is a ionic mechanism and you must think about the carbocation rearrangement. While with the PCl5, PCl3, no. Okay. And that was the last question. That was the last question from the chapter. That was the first organic chapter from second year topic, haloalkane, haloarene. With the important other chapters, we will meet in another class. Till then, bye. See you. Take care.